that's the name. We call ourselves Build Informed. It's a startup. We started 3 years ago with 3 persons. Now we are 12 persons from several disciplines like infrastructure or whatsoever, software development, trainings. We do nearly everything. But first of all, I want to present you our team a little bit. Kannst du weiterschreiben? Is it okay about language, something? You can understand me? Okay, nice. Okay, this is our team nowadays. There is one person missing, but it emerges very fast, so we can make a photo every week. So like I said, there are several professionals in our team. We only have one back office lady who does all the stuff. The rest are all professionals like architects, engineers, and software dev, like I said. So, let me give you a short overview what we do. Is interesting. So the first thing is we provide architects with the necessary technology. So if they are not into BIM, if they are not fit for building their models, their content they need in order to plan good buildings, then we provide them with some details and some adaptive components like this one. Snowhatter built some fancy building in Wattens for the Swarovski group, and then they needed just this part here. It's just one adaptive component that fixes nearly all their building, like their roof. They don't have to plan more like this. They say, we have this idea, these functions, and we build for them the content, and they can put it into their projects and be efficient. Okay. And the other thing we do is infrastructure. So we not headhunted, but one of the best BIM managers for infrastructure in Europe just changed to us half a year ago. Dimlin Fergal, amazing guy, has a lot of experience with really large projects, and now we are able to do it also. And combined with our knowledge from the former days, like from construction, etc. We have plenty cool ideas what to do with it. So I think it's the most growing or the fastest growing part of us, the infrastructure, because it's so, you can automate nearly everything. It's so line based, it's very simple. HVAC, of course, we have some HVAC experts who do all the stuff with the pipes and so on. I will go a little bit into deep on that later on, but I think I don't tell you something new. This is disciplines, they have to work, and basically they work. So next is modeling. May you know the Neue Pinakothek in München. It's a little bit older building, so it's not so easy to build. Let's say they hired a bunch of students to do it, and they modeled for about a year, and the outcome was just shit. What do you expect if you take a bunch of students and let them make something like this? So we have to throw it away, everything, and build it up new from scratch. It's just, if you know this building and if you were inside, it's a little bit, it's not straight. And we've seen that the capability of the most of the people sucks as long as if it's not a straight form, a straight structure, a simple structure, because then you have to talk with the people and define the content, define the LODs, etc., and people straight out of the university don't have a clue about it, and then they build just, waste. Okay. The other thing is, if you build a model, you have to know if it's a certain quality or not. So normally I tell the people, we invented an algorithm that makes this happen, but I don't want to fool you. It's an open source framework we developed a little bit further on, and we will merge it into the code in GitHub later. So, it exists basically, but we automate the whole process, so there is no human interaction to do it. What is it? We just check the model to the reality, so we go into the buildings with laser scanners, this stuff. This is really common right now. And then we check the models the architects built against the reality and show the client what really works and what not. So we put this into standard processes by Roche. You know, Hoffmann-La Roche is one of our customers, and now it's a standard procedure. It grows and grows, and we see that the architects and engineers, they don't plan really well, you know? It don't fit. There was no model that really fits, yeah? Because, yeah, and it's not centimeters, it's about meters. Just about the challenges nowadays, yeah? Okay, what we also do is we have an academy, so we try to provide knowledge, all what we learned every day. We try to give it away to the people, even though if it's concurrents or if it's people they are not really on our side, let's say, we love to tell them everything we know, you know, because it's not the problem. Even if they have all our knowledge, we are 3 years ahead, so I don't care. Huh? So we give it all away. So if you want something, you can have it. It's no problem. Okay? No joke. Okay, then I just want to focus on one main issue here, and then I give it to my guys, and they can talk to you a little bit. So one thing, there is the bus and everything, so these processes on the island, let's say, which defines very well how to do it, like in what order, like which process. Okay, this is one word in Europe right now, and you all know it well, so I don't have to declare it to you, I think, right? Okay, so we have the other word here in Germany, Austria, Switzerland. We do not have right processes, but we have the beginning of an evaluated content. It's the beginning, it's not the end, yeah? But it's a good process which starts and is scientific somehow and leads to good content. So we have two words, one with a good process, one with a good content. But none of them is sufficient to have a good BIM. So what do we need? Yeah? We need something different, something mixed up with it. So I want to show you something just out of the presentation. Darf ich da aussehen? Yeah, so what we've done is so just a PDF. So what we've done is we've turned it upside down. So normally the normal LOD specifications, the normal content specifications, definitions of done, whatever you call it. They say, hey, we need this and this and this parameters, this and this attributes, in this and this phase. Huh? But what they're mostly not saying is for what purpose. And so we turn it around and we say, hey, what purpose needs what parameters? Okay? So, for example, so this for real. We have worked it out. We've worked, I don't know, a year or something for it. It's just for us because we need it. And it's about HOI. So it's a definition about the money the architects and engineers get here in Europe, and it's standardized. And you have this the value you have to make, the scope you have to make, and we align to that scope. So we align to all rules here in Europe. It's okay, so you can do it like this. And so let's define a little bit more. Like here you have the dimension of the air condition and the stuff, okay? And you just need these parameters to make it happen in order to get this function. So yeah, at the beginning it was very hard to design this because the guys don't want to write their knowledge down because they say, and what is my purpose in the future if we do this? Then robots can make, and I say, fuckery, yeah? People need to see errors and mistakes and to make some agile moves, yeah, and never have to take robots for it. So, but basically, do you get me? Do you know what the problem is and what somehow the solution for me is? And yeah, okay. So I think I give the mic to Marco or to Thomas, and they will talk a little bit about, I don't know, maybe nuclear plants or something.
Hi guys, my name is Thomas. In my meantime, I'm currently leading the model creation of a nuclear power plant. Where the mission is to get reliable data or create reliable data for the demolition of this power plant. And maybe you think now you're a small team, a small startup, only 3 years old, 12 people. Which magic wands do they use to create such a big model? Or maybe not. No need. But it's not all that magic. We staged it in different processes and phases. First, gathering all the data from the existing building documentations, which are dating back about 40 years ago or something like this. And something has changed. Times change, things change. And to get from the building documentation to real-world data, we had to use point cloud. And you could imagine the big data amounts which are there, because we tried also to scan the whole building with a high resolution to get a good point cloud, and to spare people to get into there, taking up radiation, and minimize the radiation of the people, which is monitored by the state, and have a nice benefit of this. And you have to manage all this data, get it into Revit, and we made some tools where we developed geometrical shapes, which are based on which are getting placed on hand of cadastral, which is existing already, and through these geometrical shapes, which are volume, get all the size and the points into Dynamo, and automate it with a batch script into another program where we process the point clouds and get all the slices and manage it through the workset of Revit, where the geometry is in a workset and the point clouds is in a workset, and they have a relationship through a parameter and the name of the point cloud, each point cloud, and we can exchange these two things and have good performance still in the great model. The next phase is getting all the HVAC and whole equipment into the model, which we are now currently in this process with supporting us with Edgewise and all the existing documentation in plant or something, some other Autodesk products, and get all this data into one single source. And it's not construction or planning of a nuclear power plant, so you don't need all the planning parameters. You only need a certain set of parameters to get the demolition, mainly mass and some analysis of activation through the radiation to sort out which parts are really activated and not, and how they get recycled or dumped, or put away to a safe place. The other phase is structural, where the goal is to get all the relevant structural data and to make paths and ways for logistics, because you have big parts in this plant, and they all have to get out in a certain step by step, and you have to plan the whole logistics and maybe chip off or maybe make holes in walls, which is also not so easy because it's radiated, and you have to manage it and calculate the things. Next one. In this whole time, I developed a passion for Dynamo and visual programming, because we try to get results, quick results, and which is very easy with Dynamo. You can make proof of concepts very easily, and yeah, I like to develop small interfaces with other batch scripting, which is my favorite. Command line, where you can go into other programs, automate all this stuff. And now we have a routine with my teammate, where we use Navisworks, Recap, and another software, which I don't want to mention now, to make a whole process where the model quality check gets done in the program, gets converted into Recap or RCS files in Recap, and then put in Navisworks to have it all there, and it's all automated. And I find it amazing. And the next one is just a second. Please make no photos. Just a second, yeah. It's the result of the nuclear power plant. Yes, and now I'm letting Marco the stage.
Thank you. Okay, so the great thing about visual programming is that it gives the power to do all this necessary automation to the engineers, to the architects, to the people that have the real knowledge in our business. But after all, visual programming can only take you so far. As soon as things get more complex, or you need a large team to work on a complex issue, you need to go back to classical software development, and that's what I'm here for at Build Informed. So the biggest issues we try to solve is I think taking all these digitized data we have from different sources and combining them. So the big problem now is that we have data from Inventor, from Revit, from loads of different sources, and we have to manually convert them, and we have to manually check one against the other. And this is not the way it should work, and this is not the way it will work in the future. So what we do, for example, with software is we converted assemblies from Autodesk Inventor directly to Revit. This was for a big European company that had tens of thousands of parts in Inventor that they directly wanted to work with in Revit. And if you want to manually convert it, it takes probably years. And with software, you just need maybe a few weeks of development, and then everything just works. So this is one big challenge we try to solve with software. Then there's countless other areas which can be improved via software. So, for example, we build our small analysis tool for Revit. So all the actions our engineers take in Revit are tracked and analyzed, so we can tell when there's phases of high productivity and phases of low productivity, or we can tell if everybody is using the latest version of Revit. We can also quickly see where our people. Yeah, okay. I'm just going to skim over these quickly. Okay, so there's many things we can improve with software. So we're a small startup, and we need some leverage to be able to compete with bigger players. So we try to be as productive as we possibly can, and that's why we use the best tools there are. So we are focused on functional programming. I'm not going to try to lecture you about the merits of functional programming, but if you are interested in functional programming or just in trying out something new, and you are a software developer, we would be very happy if you talk to us and maybe we can work together. Okay. Yeah. So just get in touch and thank you.